I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends and mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Manuel Aguirre, Vice President Supply Chain Electrification, Ndustrial. On today's episode, we discuss energy optimization and its role in the cold storage supply chain. We hope you enjoy this episode. Manuel, welcome to the podcast.
Thank you so much.
Electrification is changing dramatically. One of the key components when you look at if you're going to call the electrification ecosystem is trucking with fleets. How are fleets currently thinking about electrification, and how do you see that changing over the next 18 months?
Well, it's interesting because if you look at electrification and how it's progressed over the last, 2-3 years, 2 years ago, everybody was very optimistic about, basically switching trucking to electric and zero emissions in a very short period of time. If you looked at the corporate goals back then, everybody was talking about 50% of transportation would be electric by 2030 and things like that. And then by 2040, 100%. Actually, the industry has been recalibrating a little bit those expectations after facing some roadblocks in terms of the technology and the current state of electric trucking where it stands today. The batteries, they don't offer the amount of range that diesel engines offer, and the amount of charging is not available to the levels that it would be needed to switch transportation, at those levels. So I think currently there's a little bit of a recalibration in terms of what's possible and what time frame, and also a little bit of an expectation on not only the technical elements on how we make it possible, but also can we make it in a way that it's also profitable or doesn't affect the bottom lines too significantly, right? So how can we balance the two competing objectives of being environmentally sustainable but also economically sustainable?
You're right on the economics, because as you know, the trucking industry from your background at Volvo, the margins are in some cases pennies. There's not a lot of margin for error or a lot of margin to move there. Is it charging, do you feel? Because obviously if you look at the passenger car side of the house, charging has made a very big difference, especially with Tesla. Do you feel for more fleets to adopt, say, a Class 6 or a Class 8 truck, there's going to have to be robust charging, especially on some of those well-traveled traditional trucking lanes? Is that going to be the big catalyst to move this?
I think that's one of them, but I think the biggest catalyst is going to be when the battery technology gets to a point where it's cheaper, lighter, and can offer longer range. Today you have that big trade-off in terms of how heavy these batteries are and whether they take some payload out of the transportation capacity, then how long of a range you get with that one route. And then also the availability of charging, which is also it's the availability, but also the power levels that are needed in order to sustain, as you mentioned, a very tight and very efficient logistics operation that runs in very thin margins, right? So how do you bring all those pieces together? That's what's proven to be slightly more difficult than was thought maybe just a couple of years ago.
Could you see a scenario, if you look back years ago, in California, this was when Governor Arnold Schwarzenegger was governor. He built the hydrogen highway, or I would correct myself and say proposed the hydrogen highway for California. Could you see a scenario where a lot of the large trucking fleets, perhaps the OEMs, get together and say, we're going to build an electric truck highway and put all the infrastructure in based on, say, every 200 miles or whatever the charging capability is, to kind of, if you want to say, test it to really learn and understand it and then grow from there? Could that become a possibility?
I think it takes more than just the trucking companies, for example, to get that in place, and it's going to require a much broader ecosystem approach. So, for example, what you mentioned, putting those chargers. Okay, you can try to install the infrastructure, but then you need the power availability, right? So then you go into the utility companies, and they have their own permitting processes and long investment cycles. Then you need to have the right real estate, right? Then you need to have the capability of charging at the power levels that operation requires, so that companies don't have a stranded driver sitting there for 3-4 hours at a time. Probably when it comes to charging, most of the operations for trucking is going to happen at their depot. So charging before and after those shift ends, and whether one charge can take you throughout that shift. And then all that combined to, the total cost of operation of that complete operation. Because today you have a lot of incentives that help somewhat close that gap with diesel technology, but even with incentives, companies are still having to do that trade-off between, going fully zero emissions or trying to maintain those slim margins that you mentioned.
Is permitting, is that the biggest headache, hiccup, or holdup? Because you have some projects, oh, yes, we can get the technology, we can get the funding, and then all suddenly the permit man shows up. It'll be 18 months, 24 months. Is that the biggest hiccup in this whole electrification process?
I don't know if that's the biggest. That is one, and you know that permitting is local, right? So it changes from each municipality to each location, but it's certainly one. And the long lead times is one of the obstacles that companies are facing as they set into their electrification journey.
And then the other aspect of this is the power. At some locations, as you well know, and we'll get this in a little bit, are not near substations. They don't have access to high voltage. They have to run lines. Where is all that energy going to come from? Is there enough energy today to support the electrification of warehouses, the electrification of trucks? Is there enough energy today, or do we need, as they're seeing in Silicon Valley, this big push towards nuclear?
I mean, in aggregate, if you wanted to electrify the whole industry overnight, the answer is no, right? There's not enough energy today, but we don't have to electrify it all overnight. We have to be smart on, what we electrify when and what's the right pace of adoption. I think the energy availability can be made available, right? It may require a combination of things, whether it's nuclear, whether it's solar and battery storage, DERs. Many companies in this space are getting ahead of it by installing solar panels on their roofs and battery storage technology to alleviate, to some extent, the demands on the grid. Then there's also, a smart management of that energy, which is kind of where Ndustrial plays. How do we help those companies avoid when energy is the most expensive or it's more scarce, and then prioritize times of the day when energy is more plentiful and available?
Industrial's focused, you're focused on the cold chain, supply chain. How do you optimize the energy for that? Because when you're in cold chain, obviously some of your customers, they have to keep the product at a certain temperature all times for the perishable or medical for various other reasons. How do you optimize that with fluctuating rates where your customer, your client, has to have this temperature at this exact temperature throughout the entire process?
Yeah, no, that's a great question. So if you think about refrigerated warehouses, at its essence, it's a massive thermal energy storage system, right? So you're not storing cold, but you're removing the heat and keeping this refrigerated. But to some extent, you have some ways to control when you're activating the heating systems in a way to bring it down or let it drift, right? So the temperature can vary within a certain range. So by choosing when you bring the temperature below that range or to the bottom side of the range and then allow it to drift, you can essentially curtail your operations or a big part of that energy consuming operation at the times when those peaks are the most critical, right? So then the question becomes, how do you identify those peaks? And that's where kind of the secret sauce becomes on trying to predict when, based on historical patterns, as well as weather data and consumption data, to understand, when to curtail and try to send those signals ahead of time so that companies can react to it.
Where does battery storage come into the picture? Do these sites have a battery storage that goes into your system to help you further optimize their operations?
Well, certainly battery storage is part of the solution. Today, you don't see that many deployments of batteries, but we foresee that will become a bigger and bigger piece. Again, it ties back to the economics of batteries and the capabilities that you see today. But as you may know, the price of battery storage is coming down pretty significantly over the last few years, and that's expected to continue. So as this happens, more and more battery projects will become feasible, and then the return on investment of those projects will become, more and more attractive. So we do foresee that batteries will be a bigger part of the solution as we move forward. Actually, at Ndustrial, we recently had a B round of funding, and one of our strategic investors is ABB, and part of their offer is to go deeper into the battery piece. That's kind of how our offer ties back to what they're doing.
And then your software layer will then go on top of the battery as well. It will carry over.
That's correct. Yes, our software layer, as I mentioned earlier, or I guess before we started, we have two pieces of software. One that it's more of a front end that allows customers to visualize and understand and manage their energy consumption. But there's a backend layer that integrates data that we collect from a number of different sources. First, data that we have is through smart meters and IoT devices that we deploy in those facilities, but also we integrate with third-party data from battery management systems, warehouse management systems, weather data, utility rate data. So by putting together those data pieces, we are able to provide significant insights and also visualize and manage the overall energy profile of a facility and also of a portfolio of facilities. So many of our customers have multiple sites, across the US and across the world, and they're able to visualize and compare each site, to other sites in their portfolio and make optimizations.
Are the optimizations automated? So some of your customers will just use aggregate numbers, hundreds of thousands of square feet to encompass. You can use millions of square feet. Lot of stuff to manage. Does the Ndustrial software platform, does that automate that whole process for them?
So what we do in terms of optimization of the energy consumption is we identify curtailment signals that we can send to them based on predictions of where those coincident peaks are going to happen, and allow them to get ahead and take advantage of those opportunities. We also integrate data of those disparate systems to produce new insights. For example, we measure the amount of throughput that facility is producing, and when those trucks are arriving, when they're getting loaded, when they're getting unloaded, when they're leaving, how long those doors are open. And with that information, we can measure the energy intensity of that production to the individual pallet and individual unit. So therefore, we can, for example, tell a customer how many kilowatt hours of energy go in each chicken wing that they produce. And that is a piece of data that allows them to think of energy more as a cost of goods sold instead of a fixed cost. And when it's a cost of goods sold, then it's something you can manage, and there's a direct incentive for them to bring that intensity down over time.
The cost of goods sold, that's a fascinating approach to energy. So I'm going to go down the road with you, because then are you pulling in, obviously some of these large warehouses have yard trucks, they have the fleet operations. Are you pulling in all of that data to get that cost of goods sold into your number?
So we do have warehouse management systems today. We do have some yard management systems integration. So Ndustrial has been around for close to 10 years, a little over 10 years, and so far it's been mostly focused on facility energy management. Now we're expanding our focus into the fleet and the transportation sector. And that's basically in two areas, right? One is the yard operations electrification. So it could be yard codes, it could be the eTRU, the reefer trailers, right? The transport refrigeration units. There's most of them are diesel today, but that's one of the electrification opportunities that we're actively working on. And then longer term, it's also the heavy duty trucks, right? For those companies that are ready to make that switch, we can help them transition into the fully electric trucks. But we see that, at least in the cold chain, the immediate opportunity starts with these TRUs.
When you're looking at reefers, obviously they're more energy intensive than a traditional truck. Are you seeing large declines in range, or is it your software able to kind of optimized for the energy that's used in the reefer when it's going from point A to point B?
So the reefer, and we're talking about a reefer trailer, right? So the unit is pulled by the tractor and is detachable from the tractor. But the use case that we see the most is basically a reefer that has a diesel-powered cooling unit, right? That runs independently of whether the truck is in motion or not, right? Because a lot of these trucks come into these large facilities, they drop the trailer on the yard, and then the facility takes over. And then whenever, depending on their schedules and their production, scheduling, they load and unload those trailers with refrigerated content. What happens is that trailer ends up sitting at the facility for maybe 6 to 8 hours at a time, whether it's in the yard, whether it's in the dock, just burning diesel, burning, fuel. And this is not one trailer, right? You can have 30, 50, 100 trailers all burning diesel at the same time at the facility, creating noise pollution, creating obviously emissions pollutions. And that is where we see the biggest opportunity, because there is mature technology today that allows those TRUs to run on electricity, at least when they're at the facility. And then you can reduce your emissions by, 80%, and also cut your cost by at least 50% at the same time. And therefore, companies don't have to make that trade-off that we were talking earlier, right? They don't have to choose between, being environmentally conscious and maintaining or having economic sustainability. They can do both at the same time. So that's kind of where why we're focused on this TRU opportunity initially.
It's a big opportunity. It's a global opportunity.
Yes.
Trailers, they start one place, they end up another place, they go another place. Sometimes there's no exact pattern for where it's going. How are you getting all this data into your system? Are you putting connectivity and sensors in these trailers? How are you getting all that data into your platform?
Well, we're working with customers, right? Our technology is already deployed in over 400 refrigerated storage facilities all over the world. So at least we have that as a starting point. We know what trailers are coming in. We know how long they're staying, both either in the yard or at the dock. We know to a greater extent how much, how many emissions they're creating, how long it costs them to operate in that way. And also we know where they're going from one place to the other. And we know who those customers are. So we're basically working with those customers because if you think about it, the most efficient way of electrifying is if you have a route, this electrifying both ends, right? So you can go from point A to point B and take advantage of those electrification strategies on both sides. So by doing that, we are able to leverage the existing logistic networks to start more of a kind of an electrification network for TRUs. And that may, as you can imagine, that includes a multitude of stakeholders. It could be the 3PL, storage facilities. It could be the food producers. It could be, on the other end of the spectrum, the retail companies and their distribution centers. So as we start mapping those logistic routes on any specific customer, we start putting all these pieces together so that we can compound those savings for each customer and then, reduce the overall cost of that logistic operation.
When a customer approaches you, also a lot of your customers are multi-site. Do they start with one site and then gradually add on 5, 6, 7, 8? Or do they come to you and say, hey, we want to electrify the whole thing? What do we do? What does that look like?
No, it's the former, right? The way we approach customers is, let's take a stepped approach, right? We want to start with, a handful of routes, maybe around a central hub location, like a refrigerated storage facility, and then start mapping those routes. And then where are those trailers going back and forth, and then go on both ends of that route, maybe 2 or 3 routes, a handful of trailers. And then once you have that, we can measure, right, the impact on that customer's operation and really validate those savings, that those savings are real, that they have a return on investment to be made, because obviously the customers need to invest on the the hybrid reefer traders, which is different from the traditional diesel-only traders. But that's part of the normal upgrade cycle, right? These reefer traders have a lifespan of maybe 7 to 10 years, right? So as they get to the point that they need to update, we create the incentive for them to switch to the more environmentally friendly hybrid model, or eventually it's going to go to zero emissions, fully electric traders. There's a couple companies developing this technology, and it's not fully mature yet for the fully electric, but we see that is the progression in which this industry will continue to evolve.
There's a lot of progression. There's a lot of interesting individuals that are building that technology now. When you're looking at routes, or some individuals call them lanes, is there a certain length that you're looking for when you're sitting down with your customer? Perhaps it's Dallas to Houston and say 300, 500 miles. Is there a range that you can get is best to optimize the data so you can really learn and show your customer, hey, and build from that?
So from a reefer point of view, we are electrifying the time when the reefer is stationary at the facility, right? So it doesn't really make a difference on how long that distance. Obviously, if it's shorter, then there's a less amount of time that it's on the road, and that part of the journey is still being run on the diesel engine. So therefore, we are pretty much agnostic to where those lanes are. We are more focused on kind of seeing it in aggregate and try to identify the key points where we have the longest utilization, right? Where are those traders sitting the longest? That's the key. And we have, to a great extent, that data from our deployment with the warehouse cold storage facilities. So then we need to work upstream with the customers on site, right? And connect those two and start mapping those logistics routes. So that's the way we are approaching it. It's less on which lanes and more where are those traders sitting the longest and where's the biggest opportunity, right? To cut the emissions and to cut those costs, in a bigger way.
If some of these trailers sit for a long time and you're getting the weather data, do you say customer A, if you move your trailer to this side of your facility, you get less sun, so it's going to take less energy? Do you go to that minute level of detail in your data?
No, we have not looked into kind of where is the best place to park those trailers. We do foresee. So first, the first step is to help those customers install the infrastructure so that they can plug in those trailers, right? So that's where the biggest gains are going to be found for a customer that runs these diesel trailers for long periods of time on the yard. From there, you can take, how do we continue to evolve the cost of that energy and the usage of that energy? And there you can move into, for example, deploying of solar canopies, right, on top of the trailer that would produce two factors. One is generating solar energy, obviously, but the second one is generating shadow, a shade for those trailers, and that will reduce the amount of energy needed. So it's like a double benefit. And then battery storage, as you mentioned earlier, right? If you combine that with battery storage, then you can compound the effects of curtailment and taking energy both from the sun as well as from the grid when it's the most convenient, and using it when it's needed.
Then if you look at yards, we've both been to yards. Some are better managed than others, but they're a rugged environment. What are your customers doing to make sure the infrastructure is always running? Because some of these yards, you see that the charger's broken, and then they got to go call I'm just going to use a simple term, the charger repairman. Well, he's got to come out and do it. How do your customers ensure the infrastructure is always? So you have the software, but if the infrastructure to enable your software to work doesn't work, it's like, how do your customers ensuring that the infrastructure is always up and running?
So yeah, when it comes to this infrastructure, we are actually more than just a software provider. We're helping the customers do the turnkey installation. So we are going out there, and as I mentioned, we just took an investment from ABB. They have a company that does EPC and installation of these pieces of equipment. So we're working with them to not only put the chargers or put this infrastructure in place, but also to keep it operational and developing some processes to repair it when it fails and keep it working. our software also allows us to verify when things are not working and creating some triggers early on. But even if that's not happening from the software point of view, we are relying on the existing processes at these facilities. There's always a yard person, right, that monitors, for example, the fuel level on the reefer trailers and the temperature conditions of those reefers. And that person has access to our platform so that they can notify through the platform very easily when something is not working as planned.
What's next for Ndustrial after cold chain? You have the software, it's built. From what I've gathered and all the research I've done, it's very highly scalable. So I'm curious, what's next after cold chain?
Well, so let's start by saying that cold chain, we still have a long journey, right? The cold chain is a big and growing market that we are, really, really good and really expanded in it, but there's still a long ways to go, both at the facility level and now expanding into the transportation space, both from the warehouse operators to the food producers and so on. So we do have a long runway there. That said, yes, we are looking at other verticals. Actually, we do already have customers in other spaces like textile manufacturing. We have in some recyclers of materials. So we are looking to expand into any application that really takes a large amount of energy, because that's where we can help those customers realize savings, increase their intensity of their production, and so on. We always say that our platform is 85% completely scalable, but there's a 15% that is custom, right? And that's kind of where the secret sauce is, when you can really tailor that platform to the specific needs of each customer. And obviously, within a vertical like cold chain, some of these needs are similar. But then as you go into a different vertical, those needs will change. But part of the advantages of being a small company is that we are very customer focused and very flexible, so that we can iterate our product and our different offerings rather quickly, as opposed to some larger companies that may take longer to do that.
You and I both know, we have data to back it up, the demand for energy is only going to grow. It's only going to grow over the coming decades. And we both know you need energy management for not just your applications, but for a lot of industrial, probably all industrial applications. In your opinion, Manuel, what does the future of energy management look like?
So first, energy is going to become a little more complex, right? You have a lot of DERs being deployed. You have batteries being deployed. You have the grid with its own conversion from high carbon to low carbon sources. So all that is going to take many years to adjust. But then it's a matter of I think it's all going to be about the data, right? Whoever owns the data and the intelligence around energy is going to be the winner, right? Understanding where that energy is coming from, where that energy is being used, what is the context, right? You mentioned weather earlier, right? It's not the same to keep a Wisconsin cold storage facility cold as it is one in Phoenix or in Houston, Texas, and then you combine the energy, the utility issues, or they have the energy markets with its own characteristics in each place, and in some places you may have a hurricane coming through and energy costs go up through the roof, and how you get ahead and manage that. I think that's what's going to determine who wins in that space. Then the other piece is, the new energy users, right? That were not there in the past, right? We mentioned transportation. That's going to be a big one. Maybe trucking is not ready for prime time today, but it's going to happen. It's a matter of when that's going to happen, right? And how are we ready to electrify more and more routes as the technology becomes capable of supporting those longer and more demanding routes. You have, AI and the whole data center space, and those are going to become large energy consumers as well. So yes, energy is going to continue to go up. Energy management is here to stay, and it's only going to get smarter. And the more we can combine and integrate different sources of data, the better we're going to be able to manage that.
I was in Houston a few weeks ago, and I've been to a lot of places. I've seen a lot of things, weird things, interesting things, cool things. And in Houston, my goodness, warehouses as far as the eye could see. We're going miles and miles and miles. We got Igloo, Domino's, going down the chain. I was amazed. Millions and millions of square feet. From an energy management perspective, how the heck do you manage all of that energy when it's football field after football field of warehouses? How do you manage all of that?
I mean, those all add up to the grid and add to the demands on the system, right? So you manage by basically you cannot just take a macro view, right? You need to get into the details. You need to understand how that energy is being used, which production processes, and where the waste is, and how you can reduce that waste. It comes down to industrial engineering 101, right? But you cannot manage what you don't measure. So the first step is, measuring, baselining it, normalizing, and combining the different sources of data so that you can have insights and know where the opportunities are.
You have to, because without energy management, in my humble opinion, Houston wouldn't be where it is today, just purely based on the amount of warehouses that I saw.
I mean, Houston is just one piece, right? Go to Southern California, the Inland Empire, and you have warehouse after warehouse after warehouse. So it's not just an isolated issue. It's a massive issue that goes not just in the U.S. but all over the world.
It's an issue, but it's an opportunity. If you build really great software like Ndustrial's doing, it's an opportunity. It's an opportunity to grow. Manuel, this has been a really insightful conversation. As we look to wrap up for today, what would you like our listeners to take away with them?
So I would say because a lot of people put the energy transformation and these challenges into this failed choice, I guess, between you can either be green or you can either be economically sustainable. And I think my main message is you don't really have to choose. If you're smart about it, you can do both. There's many areas in which you can go today with proven technology and reduce emissions and reduce the costs and make great efficiency gains that amount to tons and tons of carbon emissions reductions, and doing that at the same time that companies can get a return on that investment. So that's my main takeaway, is that you can do both. You just need to look in the right place and be smart about it.
Reduce emissions, reduce costs, call Ndustrial. Today is tomorrow, tomorrow is today. The future is industrial. Manuel, thank you so much for coming on SAE Tomorrow Today.
Thank you so much. Have a good one.
Thank you for listening to SAE Tomorrow Today.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.